this series, we're going to look at how modern sealer and adhesive technologies are used to extend the life of metallic products. To demonstrate, we're going to use an example that's familiar to everyone, the automobile. And it's a great example. You see, sealers and adhesives are used extensively throughout the body-making process to prevent corrosion for the express purpose of extending the life of the automobile. Hem, flange, weld through, seam and underbody sealing processes, as well as joining parts with adhesive to eliminate fasteners that pierce the metal, are all common. So let's start with a brief history of how this came to be in the first place. Prior to the 80s, rusting was a common occurrence for all cars. It was just a part of the normal life cycle. The lower doors and rocker panels were usually the first to go, followed by the floor pans, and then the wheel wells raced the bumpers to disintegration. Even the hood, deck lid, and the roof got involved. No parts were immune. When I learned to drive, which was a long time ago, there were standing jokes about rust in the automobile. We joked that our cars were rusting even before we drove them off the dealer's lot. And we also joked that the best uses for Coca-Cola were quenching your thirst and taking the rust off your bumper. This is why the Midwestern United States came to be known as the Rust Belt. But this created opportunity. Aftermarket companies sprang up to undercoat your car to prevent rust. And automakers understood it too. For a while, they even offered undercoating as an option while they sought a solution. Then, along came modern sealer and adhesive technologies, which offered the opportunity to prevent corrosion in places where it was most prevalent. This was far better than aftermarket solutions, which involved drilling holes and installing plugs after it was sprayed, essentially creating more problems than they solved. Sealer and adhesive systems could be incorporated into both the design and the manufacturing process. At first, these were applied manually. While a significant improvement, this proved unreliable. In the 80s, robotics were just coming into their own, and they offered the opportunity to automate those repetitive, tedious, high-precision tasks of which humans quickly grow tired, like the application of sealer and adhesives. But there was one major problem: eye-hand coordination. You see, a human could watch the bead as they were applying it, and they could change their speed, angle, distance to the part, etc. to create a good bead. A robot could reproduce the same path, speed, distance, and angle to the part time after time, but it couldn't make adjustments on the fly for changes in viscosity associated with changes in temperature. In this single example, we see some of the more common sealer and adhesive dispensing defects. Things like thin beads, where there may be insufficient material applied to do the job. Heavy beads, where too much material may be applied. This can lead to slumping, where the bead flows out of its intended area. Then, there's starting blobs and ending blobs. Again, where too much material may be applied for the application. Finally, there's tail off, where the viscous material is dragged away after the gun is shut off. All of these can occur in manual operations in spite of an operator's best efforts, but a robot can mindlessly repeat these problems part after part after part. These issues combine to produce results like this when our customers expect this. For a while, it appeared as though this really was not a good application for robotics after all. Then, in 1990, Clair Systems introduced new methods and devices for controlling the temperature and therefore the viscosity of the sealer or adhesive as it was being applied. This made the application viable, and the rest is history. Robotically applied sealer and adhesive is now the norm throughout the industry, and virtually every successful system incorporates some form of temperature control to stabilize material viscosity. In our next segment, we'll examine the fundamentals that make viscosity such an important property in sealer and adhesive applications. I hope you'll join us.